Today we are going to review how to do three things. The first one is how to rewrite a fraction as a decimal. And that could be like, sorry about that noise. That could be like getting half and turning it into 0 and 5/10. Then we are going to do the opposite. We are going to get a decimal and we are going to write it as a fraction or a mixed number in simplest form. So again, it could be a fraction or a mixed number. And this could be, for example, you get 5/10. 5/10 turns into 5/10, and you simplify that and you get half. Okay, so it's not only changing the decimal into a fraction, but finding the simplest form of that fraction or mixed number. The next thing that we are going to do today is we are going to find square roots, and cubic roots by solving for x. Okay, and the last part is going to make an approximation without using a calculator. Okay, so we are going to get irrational numbers and we are going to make an approximation. So make an approximation without using a calculator. Okay, so for example, we know that the square root of 2 is an irrational number, so we are going to find an approximation. So that square root falls into between which two numbers and which one would make more sense. So those are the 4 things that we are going to review today. So let's get started. Okay, so let's get started on page 12 of your GoMath. If you don't have your book, then I will provide the online version of this. Like I said earlier, we are going to write each fraction or mixed number as a decimal. First problem is 2/5, and we want to write that as a decimal by dividing. So we are going to rewrite each fraction or mixed number as a decimal by dividing. So we are going to get 2/5. Oops, that's too thick. Let me try that again. Okay. So we have 2/5. Remember that we read this line as divided by. So we are going to say 2 divided by 5. Okay, so 5 goes into 2 0 times. That means we have to put a 0. We write down a decimal and we also write it on the bottom. And we can write as many decimals to the right of the decimal point without changing the value of that number. So we are able to do that. Okay, so now we look at 20. How many times does 5 go into 20? Well, 4 times. 4 times 5 is 20. Then you subtract that, you get 0. So it's 4/10. Right, that one was easy, so you come back here and your answer is 0 and 4/10. Okay, rewrite 7/10 as a decimal by using division. 7 divided by 10. Your numerator is your dividend and your denominator is your divisor. 10 goes into 7 0 times, so you add a decimal point, and remember, when we add a decimal point, we can add as many zeros as we want to the right of that decimal point without changing the value. So now we say 70. 10 goes into 70 how many times? 7. 7 times 10 is 70, and then you subtract that, you get 0. Therefore, your answer is 0 and 7/10. Okay, I am now going to show you how to change a mixed number into a decimal. Now I'm going to show you how to write a mixed number into a decimal point so that you can solve the rest of the problems on your own. So we have 2 wholes and 3/8. The first thing that we want to do is want to separate the whole number and the 3/8, and we are able to do this because that's what the mixed number says, that we have 2 whole numbers and a fractional part. Okay, so now I'm going to take the fractional part and rename it as a decimal. So 3 divided by 8. 8 goes into 3, oops, sorry about that, 8 goes into 3 0 times. We add the decimal and we can add some zeros so that we can solve the problem. And remember, adding zeros to the right of the decimal point doesn't change the number. Okay, so now we ask ourselves, how many times does 8 go into 30? Well, 8 goes into 30 3 times because 8 times 3 is 24. We subtract that and we get 6. We bring down the next 0 and we get 60. Now, how many times does 8 go into 60? It goes 7 times. 7 times 8 is 56. We subtract that, we get a 4, and we bring down another 0. Now, how many times does 8 go into 40? It goes in 5 times. 5 times 8 is 40. Okay, you subtract that. So 3/8 as a decimal is 0 and 375. Now we have the 2, and we now have the decimal part, which is 0. Okay, 375. Now we just add them together. So we get 2 wholes, 375, and this will be our answer. So again, when you get a mixed number and you want to change it into a decimal part, you only work with the decimal part, and then at the end you add the whole numbers to the left of the decimal point because those are your whole numbers. All right, so your answer for number 5 is, all right, now I'm going to show you how to change a decimal into a fractional part. Okay, to do that, we are going to use our place value chart, and I just want you to focus on the ones and the decimal part. So you have ones and tenths, hundredths, thousandths. So to the right of the decimal point, you don't start with ones, you start with tenths right away. So ones and tenths, hundredths, and thousandths. Okay, so when we look at our first decimal, it's 0 and 675. Well, remember we have tenths, hundredths, and thousandths. Therefore, the 5 ends in the thousandths place. That means that our fraction will look like 675 over 1,000. And our next step is to simplify that, because it says right here that they want the answer in simplest form. Okay, so we can divide Okay, so I wonder if both numbers can be divisible by 500. 500 and 500. But this one doesn't divide evenly into that, so no. 5. That would take us forever to know, because we divide 675 divided by 5, it's 135, and 1000 divided by 5. Divide both by 100, 675 divided by 100. No. By 10, 675 divided by 10. No. 675 divided by 5. Okay. 675 divided by 25. Okay. So this fraction would be very simple to simplify, because not very simple, but we can find at least one common factor between both of them, because they both have a 5. No, this is the greatest common factor. Okay. Okay, for some of you, it might be very easy to find the number that is divisible. Times a number gives you 675, and 5 times a number gives you 675. So that would be 135. If it's a large number, then you come down here and you can divide that and find 135. And then this would be 200. 200. Okay, so this 5 divided by 5 becomes a 1, and in any number times 1 becomes that number. So now our 675 over 1000 has been reduced to 135 over 200, but again that is still too large. So again, they both are divisible by 5. So 5 times a number gives me 135, and then 5 times a number gives me 200. So this one would be 40. 40 times 5 is 200, and 135 divided by 5 is 27. Again, this is 1. 5 divided by 5 is just 1, and any number times 1 is 1. So we now have 27/40ths. It looks that is as reduced as possible. So our answer would be 27/40ths. Let me write it over here. 27/40ths. Go ahead and work on number 8 and number 9 on your own. Remember that when a number has this line on top, this line right here, that means that it's a repeating decimal. In other words, is 0.444444, and it goes on forever. Okay, but I am going to show you how to reduce that into, not to reduce that, how to rewrite that repeating decimal into a fraction. Now we are going to change a repeating decimal into a fraction. Okay, and we stated earlier that a repeating decimal is the same as saying 0 and 4 forever, right? It never stops. So we just add that line. Okay, in order for us to be able to change this repeating decimal into a fraction, we have to say that x equals to 0 and 4 repeating. So we're going to just say that the value of x is 0 and 4 forever. Okay, then we are going to multiply that by 10. So we are going to multiply 10 times x, and we are also going to multiply 0.4444 times 10. So if you multiply this times 10, basically you just move one decimal point over, and you would get 4 and 4 repeating, right? So I'm going to get, so if I do 10 times x, and I also multiply the 10 times the repeating decimal, I will get 4 and 4 repeating. Again, first I just use my repeating decimal and I assign that value to the letter x. Then I multiply that letter times that variable times 10, and I also multiply the other side times 10. So if you multiply this side times 10, you also have to multiply this side times 10. And when you multiplied x times 10, you get 10x. If you multiply 0 and 4 repeating times 10, you just move the decimal point over 1, so you get 4 and 4 repeating forever. So the next thing is for me to subtract the value of x. Remember, the value of x is just 0 and 4 repeating. So if I subtract x from this side and I subtract x from this side, I am going to get 9x equals 2. So if we get 4, let me erase this. All right, so now if we get 4 and 4 repeating, and we subtract for repeating, we are just going to be left with 4 because this for repeating and this for repeating were subtracted from each other. So now I just get 4. Because again, we had said that x is equal to 0.4 repeating. So now I am left, so I subtracted the 10x, I subtracted this value from the 10 and also from the 4 and 4 repeating. I am left with 9x and equals to 4. I am going to divide both sides by 9 and I get x. 9 divided by 9 is 1, so they cancel each other out. X is equals to 4/9. So my answer is 4/9. And again, if we were to do it again on this side, we would say that we would going to give x the value of 0 for repeating. So then we would multiply 0 for repeating times 10, and it would give us 4 and 4 repeating. So now we subtract the value of x, which is this one, and we get 10 minus x is 9. And in this side, instead of writing x, I'm just going to write the value. So it's 0 and 4 repeating, and I'm left with 4. So then you divide both sides by 9 and you get 4/9. Now, when you are multiplying a repeating fraction, a repeating decimal that is in the hundredths place, for example, 0 and 93 repeating, then you are going to give x the value of 0 and 93 repeating, and then you are going to multiply times 100. In our example over here, we multiply times 10 because it's in the tenths place, but over here the 3 falls in the hundredths place, so therefore we are going to multiply times 100. So we're going to multiply both sides times 100, so that would be 100 times 93 and 93 repeating, because remember, multiplying times 100, basically you just have to move the decimal point to place to the right. And then you subtract x, the value of x. The value of x is 0 and 93 repeating. So you get 99. X is equal to, this one's cancel out because 93 repeating minus 93 repeating is 0. And you get 93. Then you divide both sides by 99. And your answer would be 93/99. Okay, so again, if your repeating decimal had 3 repeating decimals, then you would multiply times 1,000. Okay, so the only thing that changes is the one that you are multiplying by, depending if it's in the tenths place, the hundredths place, or the thousandths place. Now do number 11 and number 12. Again, number 11, you're multiplying times 100 because it's in the hundredths place. Number 12, you're multiplying times 1,000 because it's in the thousandths place. But it's the same steps as number 10. You just have to multiply times 100 or times 1,000. And now we move to the next part, which is solving an equation for x. Before we move on to the last 2 parts of this lesson, I want to remind you of what perfect squares are. Perfect squares. Because perfect squares will guide us into solving for not perfect squares. So, for example, 2 square is 4, and 4 is a perfect square. 3 square is 9. 9 is a perfect square. 4 square, 16 is a perfect square. 25 is a perfect square. 36 is a perfect square. 49 is a perfect square. 64 is a perfect square, and you could keep going on forever. So for example, if they want you to find the square root of 3, then it's not a perfect square. But we can use perfect squares to find an estimate of that. Okay, so now that we know what perfect squares are, let's go back into the lesson. So we want to find the x squared equals to 17. That's our question. So in order for us to solve that, we have to find the square root. So we have to find the square root of 17. So we would have to find the square root of both numbers. So x times x would be x squared. So the square root of x squared is x. And the square root of 17 is not a perfect square because we don't see it here. Therefore, we know that 17 is between the perfect squares. It's between 16 and 25. So the square root of 17 is either, so it's between 16 and 25, so the square root of 17 is plus or negative 4 plus or negative 5. Now, if you 4 square is 16, therefore the square root of 17 is closer to 4. And you see this squiggly lines, they're not straight because that means they're not equal. The square root of 17 is not 4, but it is close to 4. It's an approximation. Okay, so you can say that the square root of 17 is either positive or negative, and it's very close to 4. Because again, 4 squared is 16, so it's close, but it's not the exact answer. Alright. So in the next one, you do the same. To be able to solve for x, you find the square root of both sides. The square root of x squared is x. And then you find the square root of 25 and the square root of 289. Now the square root of 25 is 5. And since this has straight lines, that means that 289 is a perfect square. So go ahead and find that. So for example, you can start at a random number, 50 square. What's 50 square? Well, 5 times 5 is 2500. See, that would be too big. So find the square root of 289. Okay, so this is something that you can definitely do on your own. Find the square root of 289. In other words, what number times itself gives you 289, and that number would go here. Alright, and then again, approximate each irrational number to one decimal place without a calculator. Okay, so now we want to find the square root of 5. So let's look, the first thing is to look at our perfect squares. Okay. So we want to find the square root of 5. It falls between 4 and 9. Okay, so let's go back. And we know that the square root of 5 is greater than the square root of 4, but it's less than the square root of 9. Okay, so we know that our number is in between 2 and 3, but we want to know to 1 decimal place value. Okay, so let's do an approximation. Okay, so now that we have the two estimations, we see that the square root of 5 is closer to the 4 than it is to the 9, because the difference between 5 and 4 is 1, and the difference between 5 and 9 is 4. So we are going to say that the square root of 5 is closer to 2. So now I'm going to do an educated guess. And so since the square root of 2 is closer to the square root of 5 is a lot closer to 2 than it is to 3, I'm going to say about, let's say 2.3 times 2.3. Okay, and then it's 1, 2, 1, 2. Okay, if that would give us 5 and 29, that is a lot bigger than 5, so we have to go maybe 2.1. Let's try 2.1. So again, you have to use trial and error. And then 1, 2, 1, 2. So this one be 441. It's very close to 5, but I still want to try 2.2. Let's see, 2.2 times 2.2. Yeah, 2.2 would be the closest. 2.2. So again, you see the squiggly lines, that means they are not equal, but they are very close. So first you have to find the two perfect squares that your question falls in between, and then you have to determine if it's closer to the square root of 4 or is it closer to the square root of 9. We realize that 4 is a lot closer to 5, so we went for the square root of 2. Then we know that it has to be a little bit bigger than 4, but it has to be less than 3. So then you do as an educated guess and try things out, and we realize that 2.2 would be as close as we can get to finding the square root of 5. All right. Excuse me, so go ahead and do number 17 and number 18. And we said that 2.2 was the estimation that we did. And then also do number 19. And we'll continue back next time.